Hello everyone, good to see you again. I call myself Mr. U.S. Patil, working as assistant professor at Sharad Institute of Technology College of Engineering, Edra, Ichalkarji, which is at Kolhapur district, Maharashtra. Friends, today we are going to see group technology, which is used in flexible manufacturing processes or systems. So let's get started. What exactly group technology is? The group technology is a manufacturing technique and philosophy to increase production efficiency by exploiting the underlying sameness of component, shape, dimensions, process routes, etc. If you see, uh, in brief, group technology is a manufacturing philosophy in which, as we say here, similar parts are identified and grouped together to make advantage of their similarities in manufacturing and design. Similar parts are arranged into part families as well. For example, you can say a plant producing 10,000 different parts number may be able to group the vast majority of these parts into 50 or 60 distinct families. Each family would possess similar design and manufacturing characteristics. Hence, the processing of each member of a given family would be similar, and this result in a manufacturing efficiency. These efficiencies are achieved in the form of reduced setup times, lower in process inventories, better scheduling, improved tool control, and the use of standardized process plans. In some plants where group technology has been implemented, the production equipment is arranged into machine groups or cells in order to facilitate workflow and part handling. In product design, there are also advantages obtained by this group technology or grouping part into families. If you say, for example, a design engineer faced with the task of developing a new part design must either start from scratch or pull an existing drawing from the files and make the necessary changes to conform to requirements of the new part, isn't it? The problem is that finding a similar design may be quite difficult and time consuming. For a large engineering department, mm, there may be thousands of drawings in the files with no systematic way to locate the desired drawing. As a consequence, the designer may decide that it is easier to start from scratch in developing the new part. This decision is replicated many times over in company, thus consuming valuable time creating duplicate or near duplicate part design. If an effective design retrieval system were available, this waste would be avoided by permitting the engineers to determine quickly if a similar part already exists. A simple change in an existing design would be much less time consuming than starting from the scratch, isn't it? This design retrieval system is a manifestation of the group technology principle applied to the design function. To implement such systems, some form of parts classifications and coding is required. Why actually need this group technology is, we can say, the advantage: lot size decreasing, part variety increasing, increased variety of materials with the diverse properties, requirements for closure and tolerances. These are the some where group technology can be used. So as I'm telling that the part is classified, and coding is concerned with identifying the similarity among parts and relating these similarity to a coding system. A part similarity are of two types: design attributes such as geometric shape and size, and manufacturing attributes. Design attributes and manufacturing attributes. Here, if you see in a part familiar, as I told, that is design attributes and manufacturing attributes. While the processing steps required to manufacture a part are usually correlated with the part's design attributes, this is not always the case. Accordingly, classification and the coding system are often uh, devised to allow for different between a part designs and manufacturing. Whereas a part classification and coding system is required in a design retrieval system, it can also be used computer aided process planning. In computer aided process planning involves the automatic generation of process plan, or you can say routine sheet to manufacture the part. And the process routing is developed by recognizing the specific attributes of the part in question and relating these attributes to the corresponding manufacturing operations. In the present chapter, we developed the topic of group technology and part classification and coding. And we in following we present a discussion on computer process planning and several related issues even. And here, group technology and part classification and coding are based on the concept of part families. This is a part one of that families, that is part family. The similarity groups or groupings are called part families. A part family is a collection of parts which are similar either because of geometric shape or and size, or because similar processing steps are required in their manufacturing. And if you say the part within the family are different, but their similarity are close enough to merit their inclusion as a member of the part families. If you see here, if half family, this is what the examples in a part families. They might be similar in geometric shape and size, and similar process steps are required even, right? And next, if you give me saying a grouping part families, there are three general methods for solving part families grouping. All the three are time consuming and involve analysis of much of data by properly trained personnel. The three methods are visual inspection, composite part method, and part classification and coding, and production flow analysis. As we have said that grouping part families, and there are three methods that you here might be have seen four different methods. Mainly there are three. So before that, a part family is a collection of parts which similar either because of geometric shape and size, as we have discussed, the part within the family are different, but their similarity are close enough to merit their identification as a member of the part family, isn't it? If two parts are similar from a design viewpoint but quite different in terms of manufacturing, the part shows in the that constitute a part family in manufacturing, but their geometry characteristics do not permit them to be grouped as a design part family. The part family concept is a central to design retrieval system and most correct computer aided process planning schemes. Another important manufacturing advantage derived from the grouping work parts into familiar can be explained as if you see these figures as here we are seeing 13 parts within a similar manufacturing process requirements but different or design attributes, isn't it? When when we talked about group technology layout, the biggest single obstacle in a changing over to group technology from a traditional production shop is the problem of grouping parts into families. Uh, there are three general methods of solving these problems as we have discussed. All three methods are time consuming and involve the analysis of much data by properly trained personnel. The three methods are, as we have said, that visual inspection, production flow analysis, part classification and coding, and this is composite part method, that is one another important method. Or you can say here the visual inspection method is the least sophisticated and least expensive method. It involves the classification of parts into families by looking at either the physical part or their photographs and arranging them into groups having a similar features. So these are this kind of visual inspection kind of. And if you see the second one, that is composite path method, where in this method the hypothetical composite part is formed on the basis of the features of all the ways of forming such group in the future question. Figure shows the number of components manufactured on the lathe, isn't it? So this is composite, a kind of. This is what composite part enclosing of all the seven designed and processing attributes, isn't it? So if you see part classification and coding is the most time consuming and computable or complicated of the three methods. Or you can say in part classification and coding the similarity among parts are identified and these similarities are related in a coding system. The two categories of part families can be distinguished, that is design attributes and manufacturing attributes, as we discussed earlier, which design attributes which concerned with the part characteristics such as geometry, size and material. And if you say about manufacturing attributes which consider the sequence of processing steps required to make that part. The most it is the most time consuming and complicated of three this method. However, it is the most frequently applied method and is generally recognized to the most powerful of the remaining of two. And if you see the reason for using classification and coding system, that design travel, that a designer faced with the tasks of the developing a new part can be designed retrieval system to determine if a similar part already exists. A simple change in an existing part would take much less time than designing a whole new part from scratch, isn't it? And if you see authorized process planning, here the part code for a new part can be used to search for process plans for existing parts which identical or similar codes. And in machine cell design, where the part code can be used to design machine cells capable of producing all members of the particular part family using the composite part concept. Right. If you see a part coding system consider of sequence and symbol that identifies the part design or manufacturing attributes. The symbols are usually alphanumeric, although most systems are use only numbers. The three basic coding structures are, you can say, so here this is a chain type structure. This is what a coding. Before we see this coding again, we'll see that classification and coding. This is design retrieval and automated process planning and machine cells as we discussed. Uh, as we have seen that part classification and coding where design attributes and manufacturing attributes. In a part classification scheme, in a part classification scheme, uh, there are three types of systems are used for part classification on the basis of the some attributes. If you say you can say one of, then you can even you can see this that systems based on the part design attributes or design retrieval. In this base, what it concludes means here basic external shape, basic internal shape, length or diameter ratio, material type, part function, major dimensions, minor dimensions, you can say tolerances, surface finishes, and etc. It comes and the system based on that part design attributes. If you see that system based on the part manufacturing attributes, that you can say automated process planning, that would be considered or it includes the major process, minor operations, major dimensions, you can even length and dimension ratios, surface finish, even machine tool, operation sequence, production time, batch size, annual production, fixture needed, even cutting tools, etc. And if you see the system based on the both design and manufacturing attributes, where you can say it includes that basic external shape, even the basic internal shape as uh, part design attributes, and same in throughout that length and diameter ratio is also important here, and the material type, part function, major dimension, minor dimensions, even here also tolerances, surface finish, major process, minor operations, machine tool, operation sequence, production time, that is also uh, is there, and batch size, annual production, fixture needed, and cutting tools. That what some attributes are there, which where we have seen the classification, part classification. And if you see in a coding system, if you see in a coding system, Uh, there are some three basic code structures used in group technology applications. That is, one is a chain type structure, is also as a polycode in which the interpretation of each symbol in the sequence is always the same. It does not depend on the value of the preceding symbols at all. If you see this code value 1 2 3 4 5 6 7 8, that is digit value depending on chosen alphabet code. That is, if you one the material, and second is material form, and third is material property, fourth is of bending method, fifth is a tolerance, sixth is surface finish, seventh is test method, and eight is where the special requirements. So in such kind of this one of the basic coding structures is of that chain type structure. And again another is hierarchical structure, also known as monocode, in which the interpretation of each successive symbol depends on the value of the preceding symbol. So if you see here, in the hierarchical structure, the hierarchical structure is also called that, as I said, that monocode. This provides the relatively compact structure uh, which convey a lot of information about the part in a limited number of digits. The first digits, or you can say 0 to 9, uh, divides the part into the major groups such as machine part, cast parts, forged parts, sheet metal parts, etc. And the second digits, as we'll see in this uh, digits in a next slide, next video. Before that, this is what hierarchical structure, where this is a level 1 from here. This is what total part population, how the numbers of parts are here. So it would be distributed along cast parts, related to machine parts, and related to forging parts, or it may be sheet metal parts, like that. So there are the categories like that is 2 3 4, that is a level 2. And these if you say machine part, that would be rational parts, ml non non-rational parts, that would be again separated, like that. So again it would be the level of 3, I mean 5 6 7 8 9 10, like they have could distributed. So this is what one kind of hierarchical structure. And if you see next one, hybrid structure, this is combination of all, the combination of hierarchical and chain type structure. And next, or you can say, um, this is this is an attempt to achieve the best feature of monocodes and polycodes. Hybrid code seems to be best served to need this needs of both design and products as well. And if you see here, the Opitz classification, coding and system, this is where coding system is used. As before going this, we'll see about what exactly important classification and coding system in a next slide, next video. So we'll see about this in a next video. Thank you. Thank you, one and all.